It's quite a bit of water by hydrolysis. So you actually have quite a bit of metabolic water. Also, when we get rid of fluid, the kidneys are probably the major source, but we also get rid of fluid in other places. Insensible loss is what I have marked in the handout. And I think I've got it marked at what, about 900 mils? 900 mils. So a lot of that comes from the lungs. I mean, remember that one of the major things that's expired by the lungs is saturated water vapor. I mean, it's quite a bit. So a little bit from sweating, a little bit from evaporation. It'll depend on the circumstances. But from a clinical standpoint, that insensible loss can include diarrhea, burns, what else? I had something else marked too. What have I forgotten? Oh, yeah, vomiting, yeah. So you can actually get quite dehydrated by affecting the insensible loss. And for you guys as clinicians, you'll need to understand that. So in terms of total water, our body weight is about 60% water. We are ugly bags of mostly water, according to an off-world source. You've heard the quote, "We are ugly bags of water, mostly water." Well, some of us are uglier than others. So, do you think that that changes if we're lean or obese? Yeah. So you know, for a lean person might be as much as 75% water, and an obese person might be as little as 45% water. Okay. And the point here is that muscle has lots of water and adipose tissue does not. Okay, so in terms of percentage, that's true. Gosh, what did Costanzo say? We do need to know that there are other things that can affect this. So women tend to be around 55%. So there is a gender difference. And Costanzo, now let me say this with a smile on my face because I'm going to correct it. What did she say exactly? Oh, women have a higher percent adipose tissue. Kind of sounds like women are fatter than men, right? But that's not what she meant. Okay. Men tend to have more muscle in relation to other tissues, and so women relatively have more adipose tissue in relation to their muscle. And so they tend to be on this side. As we also, we've been charged by the LCME to actually try to educate you on things that happen with aging. And I think Dr. Ike's already done a little bit of that. So, elderly folks, and this is people over 80. Anything under 80 is young. Okay, elderly folks tend to have less muscle mass, muscle wasting, and they tend to fall down this, well, not all the way down, but down in this direction. Whoops, sorry. But actually, infants tend to be high. And we don't really know the reason. The idea is that they have more extracellular fluid than larger people, but whatever the case, they tend to have more body water. You would look at a baby and think that they have plenty of adipose tissue and they should be down here, but in fact they tend to be up here. So 60% water. Let me see. Now, Costanzo talks about a 60-40-20 rule. 60-40-20. And what this means is with 60% water, 40% is inside the cells and 20% is outside the cells. That's all she's trying to say. And it's just an approximation, okay? So if you think about it, 60-40-20, I much prefer to think of it as 1/3, 2/3, okay? Within this, you got about 1/4 is plasma and about 3/4 is interstitial fluid. Okay. So you're looking at me and saying, how much this do we need to remember for tests? Obviously the numbers are very variable, and so you kind of need to just have a feel for it. I think if you remember that the intracellular fluid tends to be a lot bigger than the extracellular fluid, that's a good beginning. The only thing that I would add I don't want to get confusing, but if you look in some textbooks, this relationship is totally different, okay? The body behaves like it's 1/3, 2/3. And I don't know how far I need to go on this. Part of the extracellular fluid is transcellular. In other words, it's on the other side of cells, so you can't really see it by any test that you'd use to look at it. And so this figure's not entirely accurate, but it kind of describes what the body looks like. So in terms of putting fluid into and out of the body, it tends to distribute in a compartment that's 1/3 and a compartment that's 2/3. And I think I'll just leave it at that rather than try to confuse you. So, questions? Okay. So the next section, what is it? Oh, I'll write that up. So clinical. Did you get excited by that word? Because I'm going to cross it off. Clinical measurement of volumes. So we can actually measure these compartment volumes. We have methods to do that. So how often do we do that? Virtually never. Okay, so I guess I'd better take off this clinical measurement. It can be done, but it's not. So why am I doing this stuff with you? You know the answer to that, don't you? The shelf exam deems that it's appropriate for you to understand how to do this, and so we're going to go through it. Okay? And that doesn't mean that necessarily I'm critical of the shelf exam. It's probably important that you kind of understand the process, but you will never